Okay, so what I'd like to show you is how to solve the quiz problem. The quiz involved a cantilever problem. And in this situation, you had a 5 kilogram object at one end of a plank, and then you had a 1.25 kilogram object near the other end. This plank is supported by a pivot, but the pivot is not located in the center. It's a little bit closer to the 5 kilogram object. And so the different distances are given here to the mass, to the pivot, to the second mass, and the overall length of the board. And you're asked to find the mass of the plank. You're also asked to find the force that the pivot exerts on the plank when this is balanced. And so we'll do that last. Okay, so the assumption here is that the plank is balanced perfectly, and so this is a torque problem. The net torque is equal to 0. And so then what you want to do is find a convenient pivot location to use, okay, and then use that and write down all the torques that act on the lever. So first off, let's consider what are the forces that act on the lever. So you've got basically here, you're going to have a downwards force from that 5 kilogram object pushing down on the board. The pivot is going to exert an upwards force, right? The plank itself is being acted upon by the earth, right? There's a gravitational pull. And so there's going to be a downwards force here, and that distance to that downwards force is going to be half the length of the plank, which is 1 meter. So that's one of the things that you kind of have to, basically go with. The idea that the center of gravity of this plank is right in the geometrical center, okay? And then, of course, the 1.25 kilograms is pushing down on the plank. So you have a total of 4 different forces here that are acting. 1 down, 1 up, 1 down, 1 down. And it would probably make the most sense to make this your pivot. In reality, it is the pivot, okay? So that's probably a good place to put your pivot for your calculations, but you don't have to, but for this problem you definitely want to. Notice that we do not know this force at the beginning. That's the force of the pivot on the plank. And so it makes sense to start with this as our pivot, because then we eliminate that force from the calculation. And of course this is the force we want to find. And so if we make this our pivot, we'll have a lever arm for this 5 kilograms. We have a lever arm for the mass of the plank. And then we have another lever arm out here for this 1.25. So let's do it. Around this pivot, the downwards force on this side will create a counterclockwise torque. Okay? A counterclockwise torque is coming from this force with this lever arm. So that will be a positive torque, and the lever arm would be 0.6 minus 0.1. Okay? So 0.6 minus 0.1 meters times 5 kg. And then if you want, you could also multiply that by gravity, right? 9.8. You know that that's not going to be needed here, but we'll just put it there anyway. Okay, so lever arm multiplied by the force coming from this object. The other 2 forces are going to actually be going clockwise. I should say the torques are going to be going clockwise, sorry. And I hope you can see that, because each of those is going to have a tendency to twist the board that way. So those are going to be negative terms. I'm going to write them underneath here. And so my first negative term is going to be this lever arm here from 0.6 to the center of the board, which is at 1. And so the lever arm I have here is 1 minus 0.6. I'll write that in my picture so you can see. That's 0.4 meters. Okay? And up here, again, the lever arm up here was 0.4 meters. actually I screwed that up. That should be 0.5 meters, right? 0.6 minus 0.1 is 0.5. And then m is the mass we're trying to solve for, right? It's this. And g is just g. And we do one more term. At the very end, you're going to have an arm that goes all the way from here to here, right? And so that's going to be 1.8 minus 0.6 meters. 1.8 minus 0.6 is 1.2 meters. That's from the pivot out to where that force is acting. And then you multiply that by mass times gravity. So 1.25 kgs times big G. And all that's going to have to equal to 0. So that's how you set this up, right? Now, I wrote a lot more than probably you would need to write on the quiz or whatever. Clearly, you can divide everything by G, right? Because if I divide 0 by G, I still get 0. So that just goes away. And so mathematically, what do I end up with? I end up with this term becomes plus 0.5 times 5 minus 0.4 times m minus 1.2 times 1.25. And those have to add up to 0. So I'll let you do the math on that, but this is an equation, right? And then you solve for m. And when you solve for m, at the end of the day, you should find out that the mass of the plank is 2.5 kgs. And I'll let you verify that. So that's the answer for the mass of the plank. So to recap, we had to set up the balanced torque equation, and then we took care to look at identify the forces that are not on the pivot and figure out if they're going to create positive torques or negative torques, and then add them up to cancel out. The last question was about the force of the pivot on the plank, and that's a pretty easy one. I'll just show that up here. That is going back to F net equals 0, so the whole plank doesn't get accelerated. And so all the forces should add up. Now, since we're dealing with masses here, it's easier to just use mass and then figure out the force at the end. So I'm going to have, like, let's pretend that for 5 kgs, let's just write that as a force for now. So negative 5, because it's going down. The force of the pivot is going to be up. That's plus F pivot, right? And then we're going to have the mass of the plank, which is minus 2.5, and we'll have a negative 1.25 coming from this object. Okay. Now, I'm kind of taking a little bit of a shortcut here because these aren't really forces, are they? 5 and 2.5 and 1.25, those are all kgs. And I'm trying to solve for what I'm calling a force here, but it's really going to come out to be a mass. So the pivot is going to end up being, what do we have? So we'll have negative 5, minus 2.5, minus 1.25. And so the pivot's going to be adding up to a mass of 8.75 kgs. And you multiply by 9.8 to convert it into a force. And you get about negative 86 or 86 newtons. Just call it 86 newtons. Okay. The negative doesn't matter. It's actually I made a mistake here. It actually should be positive 86 because when you do the math here, the pivot comes out to be a positive because it's an upwards thing. So I was a little bit fast and loose here with my units, right? I just used kilograms for the F net, but I can multiply through by 9.8 at the end to find the newtons. All right, so anyway, this is an important class of a problem. You should be able to solve it. And if you have questions, let me know. Hope it helped.